Alright, this is Unit 3, Section 3 notes. Focus of a parabola with the vertex at the origin. So this is something that is new to Algebra 2, so probably not anything you've ever done before, but that's okay. So this first section is writing quadratics with focus and directrix. Example, write an equation of the quadratic given the focus and the directrix. So let's go ahead and write an equation that you will need to use for these. The equation is x minus x1 squared plus y minus y1 squared equals, and then kind of the same thing, x minus x2 squared plus y minus y2 squared. So it looks like a long equation, but it actually gets pretty short pretty fast, so it's not too bad. So before we get anything else though, let's go ahead and go over a standard equation for a parabola. So we're talking about quadratics. A quadratic is a type of function where it's only y equals. Now we're talking about parabolas, so the same shape, it has the U shape. So I have a parabola. It looks like a U, but I can go up or down, and now we can add opening left or right. So there's 4 types of parabolas that we can now have. Now the equations for these is for my up down, I can do y equals 1 over 4p x squared, and my left and right would get me x equals 1 over 4p y squared. So the x and the y now flip. So you have to be careful. If I go up or down, I'm y equals. If I go left or right, I would be x equals. Alright, so 2 other things down here before we go on to the top. Let's go ahead and talk about focus and directrix. We haven't really talked about that. So a focus is just a point. It's kind of like the point that is the same distance if you do the Pythagorean theorem from every point on the graph. So focus, if I have a y equals equation, my focus is always going to be 0, p. If I have an x equals equation, I just flip them, right? So my focus is p, 0. So notice that if my equation is y, my p is in the y place. If my equation is x, my p is in the x place. So that kind of helps you keep it together. Maybe it helps, maybe it doesn't, I don't know. The other thing is if my equation is negative, my p is also negative. So if I had y equals like negative 2x squared, then my p is negative, right? That's all that means, which we'll get to that when we actually do the problems above. So for directrix, the last part down here, so directrix, for y equals equations, my directrix is going to be y equals negative p. And I'll do that. So if I have a y equals equation, my directrix is y equals negative p. So whatever p is, I flip the sign. And if I have an x equals equation, my directrix is going to be x equals negative p. Well, that's a terrible p. But again, the negative just means I flip the sign. So if you want to write that, you can. So flip sign of p. You know, however you want to remember it, it's up to you. So I have my focus is, for y equals functions, is 0p. for x equals functions is p0, and then directrix, y equals negative p or x equals negative p. And then I have my equation, my parabola, and this big long equation at the top, which we're going to use for these. So I'm going to go ahead and go up here. So my focus, look at number 1. My focus is 0, 3. So if I were to be labeling this, I could do, this is 0, I don't know why it's purple. It'd be 0, 3, but if I'm doing my formula stuff, right, it'd be 0, p. And notice this is y equals, so y equals negative p, right? So kind of the things we just talked about. So notice my p is 3. So that kind of helps. Okay, so I can use that later, and I'll go ahead and show you the way to use this long formula first. Then I'll show you the shorter way on number 2. So if you'd like, you can skip ahead to number 2. It's totally up to you. But this is where the number 2, the short part, comes from. So if I have 0p, but that's really x and y. And then this y is another y, right? So we can name that y2, y1, x1. And now I can use that formula down here. So notice I have x minus x1. Well, x1 is 0. So I'm going to have x minus 0 squared plus, and then y minus y1. y1 is 3, so y minus 3 squared equals, now here's the part that's kind of tricky. I have x minus x2. Notice I don't have an x2, so I get to just write x. So x minus x. And then y minus y2, y plus 3. Okay? Now hopefully you're good at binomial method or binomial distribution. You're expanding quadratics or binomials. So if you really want to write this whole thing out, you can. But look at this first one right here. So I have x minus 0. That's just x, right? The 0 doesn't do anything, so I don't have to do anything there. I just write x squared. Because x minus 0 is x, and then that's it. This next part, though, since I have y minus 3 squared, I'm going to have to do y times y. So I have y squared. Then I have y times 3, or negative 3, sorry, is negative 3y. Then I have negative 3 times y is positive 9. Or no, I'm sorry, negative 3 times y is negative 3y again. I'm trying to get ahead of myself. And then I have negative 3 times negative 3 is positive 9. Equals. And then look at this next part. X minus x is 0, so that whole thing just goes away. I don't have to worry about it. So now this next part, I do the same thing, right? I do y times y is y squared. Y times 3 is positive 3y. 3 times y is positive 3y. And 3 times 3 is 9. Okay? So notice some of these go ahead and cancel out, right? If I have the exact same thing on both sides, they cancel out, they become 0, I don't have them anymore, so let's find those. Notice on the left I have y squared, on the right I have y squared. Those are gone. On the left I have 9, the right I have 9. Those are also gone. So from here, notice I have an x squared, I have those y's, and then I have these y's. I'm going to go ahead and write those out just to make this a little easier. And I'm going to combine like terms at the same time. So negative 3y minus 3y is minus 6y equals 3y, and 3y is 6y. Now, I want to solve for the letter or the variable that is not squared, right? And if you look at the top of my directrix, notice it has y equals, so I want y equals. I need to solve for y. So to do that, I'm going to go ahead and move all my y's to the other side. That would get rid of those. 6 plus 6 is 12. And then to solve for y, the final step would be divide both sides by 12. So before I write my final answer, just real quick, here's my equation I'm trying to get to right here. Y equals 1 over 4p or something, right? X squared. So notice I'm going to have y right here, so that's y equals, if I have no number in front of x squared, that's a 1. So it's 1 over 12, and then x squared. That would be my equation I'm looking for. And that's it. I know I say that's it, and I was like, oh, that was a lot. That's okay. So that is the long way. That's how you do it the long way, using that long formula. There is a shorter way, and I will show you that on number 2. As soon as it lets me, there we go. Alright, so on number 2, again, I'm going to go ahead and label the top. So we have negative 2 comma 0 for the focus. That would actually give me the p comma 0, right? So I have p 0, and then directrix is x equals 2 or x equals p. I'm sorry, negative p. Okay, so here's the shortcut. If my equation that I'm trying to get to, notice I'm doing x's now, right? So let's go down here. My equation for my x is right here. X equals 1 divided by 4p y squared. So I'm going to write that up here. So I want x equals 1 over 4p and then y squared, right? So what is p? Well, if you notice, I found p already. It's right here. It's in my focus. It's negative 2. So all I have to do is go in here and do x equals 1 over 4 times negative 2 y squared. Then I just multiply the 4 times negative 2, and that is my answer. That's it. Much faster. So I'm going to have x equals, notice that's the 4 times negative 2, that's negative 8, right? So if I have a negative, I'm just going to put it out front. So I have negative 1 over 8 y squared. And that's my answer. That was much faster on the right on number 2 than on number 1. You can use either way. That's totally fine. I just wanted to show you the long way so you understand how the short way works. That's number 1 and 2. Alright, so let's move on to the next section. Okay, B, identifying focus and directrix from standard form. So example, identify the focus and directrix of the quadratic. Notice neither one of these on 3 or 4 are solved for x or y, and we have to do that first. So if we're doing steps or notes down here, first thing I would do is solve for x or y, whichever one you have in your equation. You should only have one. So I want to solve for x and y so that I can get, my goal is x equals 1 over 4p y squared, or I want to get y equals 1 over 4p x squared. So that's my goal. That's what I want to get. So I solve for x or y, whichever one I have. So let's do that first. So on 3, notice, you want to look for x or y. I have y. That's the one I want to solve for. So to solve for that, I'm going to go ahead and move my 4x squared over here. So if it's positive 4x squared, it's just the same as anything else. It'd be minus 4x squared. So I have 32y equals 0 minus is just negative 4x squared. And then, since I want y, I'm going to divide by 32. Okay, that gives me y equals, if I reduce that, 4 over 32 is 1 over 8, so I have negative 1 over 8 x squared. Now, you're probably thinking, okay, I still need the focus and directrix. How does that help me? Well, if you don't remember from the last page, or you don't want to flip back and forth, we can write this down here. So focus, if I have a y equals equation, focus is 0p. If I have an x equals equation, focus is p0. Okay, there's my focus. So let's find that. So notice this is y equals, so I want y equals, let's go over here. Here's what I want. So my fraction, notice the bottom number is 4p. So my number should always be 4 times some number. If I go back and look, that's an 8. Well, of course, that's 2, right? So if I have y equals 1 over 4 times, now notice it's negative, so I have to include negative 2. So I'm just changing that bottom number, the 8, or the negative 8, into 4 times something. It has to be 4 times a number. So negative 2 is my number. That would give me p. So this is p that I'm looking for right here. So on my focus is right here, 0, comma p. So if I go over here, my focus, so if it's 0, comma p, and we just found p is negative 2, it'd be 0, comma negative 2. So 0, 2, negative 2, sorry, 0, negative 2 is our focus. And then, I didn't write it down here, but we'll go ahead and add it down here. Directrix. So directrix, if I have a y equals equation, my directrix is y equals negative p, so I just flip the sign. If it's an x equals, directrix is x equals negative p. So since I'm doing y again, it's going to be y equals negative p, or I just changed the sign, right? So here I have, whoa, I don't want that. So I have directrix. So I'm going to have, since I'm doing y, right? It'll be y equals negative p, or my answer is y equals, since this is a negative 2 already, I just flip it to positive. So it'd be y equals positive 2. So this is my answer, and this is my answer. So I solve for x or y, figure out what my number is for p, so it's 4 times something, and then I can have my focus and my directrix. So again, with practice, this gets very quick. It doesn't take too long. So let's look at number 4. 4, notice I want to solve for x now. Wow. So I want x, which means I need to get, first thing, this negative 2y squared over here. So if it's minus 2y and I move it, it's going to be plus 2y squared. And so I'm left with 64x equals, I don't know why that's still there. Alright, 64x equals 2y squared. And then I divide by 64 because I'm trying to get just x. Okay, so this gives me x equals, I want to reduce 2 and 64, that'd be 1 over 32. Okay, now again, my bottom number has to be, I'm going to have x equals 1 over 4 times something, right? Times p. Well, 4 times what is 32? That'd be 8. So now my p is 8. That's what I'm looking for. So all I have to do, go over here, my focus. Since I'm doing x's, my focus is going to be p comma 0. So in this one it's 8, 0. And then my directrix, I just take that number and flip it. So directrix, and again I'm using x, so x equals negative p, or x equals, I go from 8 to negative 8. So there's my focus, there's my directrix. So see, with practice, this doesn't take too long. Alright, so let's go on to the next section. So C, graphing quadratics using focus and directrix. So the first thing that I would do on these is I have a point. Wow, okay, stop doing that. I have a point, my focus, right? And I have a line, which is the directrix. So with a point and a line, I can graph those and then go from there. So that's the first thing I want to do. So first thing is, there's my point. I'm going to graph that. So 0, 3. It's right here. That is my focus. Then I have my line, y equals negative 3. So then I go down. Remember, if that's y, I stay on the y-axis. I go down to negative 3 and do a horizontal line. So that is my directrix. Okay, now here's the cool thing. And if you need to write this down here, you can. Vertex is halfway between focus and directrix. So once you have focus and directrix, you can just go find halfway and that's it. Okay, so on here, if I were to count these, I would count from focus. I go 1, 2, 3, 4, 5, 6. Okay, so of course half of that is 3. So if I just go 1, 2, 3, here's my vertex. Okay, so that's easy. If you want to label vertex, you can. Now here's the other part, is my graph, my parabola, cannot open towards my directrix. There's no way. Because don't write this down, but just to show an illustration, if I were to open down, I would cross my directrix. I cannot do that. The directrix is kind of like a boundary or a wall that I can't pass. So right away, I know that I open up, because you have to open away from directrix and towards the focus. The focus should be kind of in the center of your U. Now the only other thing that you might want to do, just to see on how the graph works, is I'm going to do what we did at the beginning, where I have 0p, and I'm using y. So I have y equals 1 over 4p x squared. I'm going to plug in my p, or 3. Y equals 1 over 4 times 3. And then 4 times 3 is 12. So this number right here, this 1 over 12, this will give me, oh my gosh, this will give me what I multiply my quadratic pattern for. So remember, the quadratic pattern is the over 1, up 1, over 2, up 4. So I would multiply that. This would pretty much be my A. So if here's my pattern, I go over 1, up 1, over 2, up 4. So here's 1, 2. So 1 times 1/12, and then 4 times 1/12. Now, of course, this makes the numbers very tiny on this specific scenario, so it's really hard to graph that, accurately. Just know that it's less than 1 both times. So if I go over my vertex, I go over 1, I'm going to go up barely at all, right? I go over 2, I go up, whether it be 1/3, so it's a little bit higher. But still, it's not 1, not all the way. So again, that's all I really need, and I can just connect my dots, and that's my very wide, compressed parabola. because we all know that 1/12 on a transformation that we talked about the other day, 1 over 12a, that's a huge compression because I'm compressing by a factor of 12. That's a lot. So that's my graph for that one. So let's move on over to number 6. Again, I have two things that I want to graph. I have my focus is my point, my directrix is my line. So I'm going to go ahead and plot -2, 0. There's my focus. My line is x equals 2, so notice I'm going to stay on the x-axis. Go to 2 and then do a vertical line. And that's my directrix. Okay, again, I already know my parabola is going to open away from my directrix, right? And so I just got to find out what's halfway in between to get my vertex. So I go 1, 2, 3, 4. Okay, so 2. So 1, 2. So again, if you want to label it, there's vertex. I know I'm going to open to the left away from directrix because I can't cross that line. And my focus will then be in the middle of my U. Now I'm going to do the same thing that we just did. So I'm doing x equals 1 over 4p y squared. And since this is p0, I'm going to have x equals 1 over 4 times p, which is -2, y squared, and that's -8. So that means I would be multiplying my quadratic pattern by -1 over 8. I don't know why that just disappeared. So if I take my pattern and I'm going to go, so I do the same pattern. It's instead of going up or down, now it's just going left and right. So the same thing, right? I go over and up, or up and over. It's just, well, not enough room there. So let's go down here. So I go 1, 1, 2, 4, right? So 1, 2, so 1, 1, 2, 4. But now I have to multiply that by -1/8. The negative is what makes it go left, because I'm going towards the negative infinity. And then I want 1/8. So 1 times 1/8, of course, is less than 1 again. So I go 1 and barely, right, barely up. And then 4 times 1/8, that's 1/2. So that's a little easier to do. It's like halfway. And then the same thing going the other direction. And again, that'll give me my wide U that's very compressed. And that's it.